In this video, we're going to talk about convolution. Convolution is a mathematical method that's really helpful for computer vision projects that use deep learning. It's also used for a lot of photo editing software, and you probably use it more than you think in your day-to-day use of editing images or working with photos. Convolution has a lot of possibilities, and everything that you do with a convolution depends on the kernel you use. So with some kernels, you can take an image like this picture of a dog and you can brighten it. It's also possible to darken the image. Other kernels let you blur an image or even sharpen an image. Later on in the course, it's going to be more important to extract key features from an image that a model can pick up and make predictions on. And so the right kernel can also help a model detect edges such as horizontal or vertical edges. And these edges can create multiple convolutions and combine all of these different key features to make predictions on something like the emotion that someone's showing or whether or not there's a car. Now that we understand some of the possibilities that we have with convolutions, let's actually show how the math works. So if we take this very simple image of a person standing in front of a mountains and pixelate it, we already know that this image is really just a two-dimensional grid of pixels. And because it's a black and white image, each of those pixels only has one value. In this animation, we're going to show how we can go from an original image to a convolution on that image. The convolution example we're going to show is blurring. So for any convolution, the key is picking a kernel. And we're going to talk in the next video about what specific kernels might do. But just take this kernel as an example. And a kernel is a two-dimensional grid of values similar to an image, but it's smaller. And what we're going to do is we're going to combine this kernel with small groups of pixels throughout the whole image to create new pixels on a new image. So because this kernel is a 3x3 kernel, we're going to start by selecting the first group of 9 pixels. Essentially what we're going to do is multiply element-wise, meaning the top left value gets multiplied by the top left value of the kernel, the pixel values by the kernel. And that's going to give us a new 3x3 grid of numbers. And then we're going to sum all those numbers up into a single value. So basically, this kernel is explaining some kind of relationship in that group of pixels, and we're summarizing that relationship for that group into one single value. And luckily we know that pixels, black and white pixels in this case, are just represented by a single value. So we can actually convert this value we came up with into a pixel, and that will be the first pixel of our image. And then if we move along, we would continue that process of grabbing a group of pixels, bringing them to the kernel, multiplying them element-wise by the kernel, and then adding all those values up, converting it to a pixel, and replacing the pixel. And this process will be continued, and you'll have a sliding window go across the original image, little by little, comparing it to the kernel, creating new pixels, until you have a full image. So now if we let the convolution just work its magic, we can look at the pixels as they come, and they're blurred. And that's because the kernel was averaging all of the pixel groups together to replace them and put a new pixel. And that gives the effect of a blur.